So in order for insulin to be successful in getting rid of glucose from the blood, it needs to have sodium ready for it to push the glucose into the cells, which is why it would be retaining it. And so that compounds the problem that if they tell you to reduce your sodium in your diet, then you actually reduce your ability to get rid of your glucose.
Hello and welcome to the BC Podcast, where we show you how to optimize your health and fitness through biomarker tracking and nutrition. If you want to look and feel better, train harder or live longer, this show is for you. I'm your host, Daniel Maggs, co-founder and CEO of BC. In this episode, you'll learn about why you need more salt on a high-carb diet, not just on keto, the relationship between sodium, potassium, magnesium, and calcium, why you should avoid potassium supplements, why cardiovascular exercise can make you feel bloated, and diet strategies to avoid migraines and improve your health. Today we're joined by the lovely Angela Stanton. Angela's an expert in neuroscience, a passionate advocate for better health by nutrition, and devoted to helping migraine sufferers live better lives. She graduated from UCLA in mathematics, went on to study for an MBA and then a master's in management science and engineering at Stanford. Angela worked in Silicon Valley for a number of years and then obtained a PhD in neuroeconomics and human decision-making from Claremont. She took a course in nutrition science with a particular focus on the ketogenic diet. After a series of research and teaching positions, including at the Max Planck Institute for Economics and the Center for Neuroeconomic Studies, Angela's devoted herself to educating people about nutrition, hormonal health, and dealing with migraines, and this led her to develop something called the Stanton Migraine Protocol, and to publish Fighting the Migraine Epidemic, a complete guide of how to treat and prevent migraines without medicine. Angela, thank you so much for joining us.
Thank you. Happy to be here. Thanks for inviting me.
Let's start by talking about migraines. What is the Stanton Protocol and how did you come to develop this? What have you learned through developing it?
Okay, so the Stanton Migraine Protocol actually, well, I'm a migrainer. I have been a migrainer all my life from about age 10 on, and it really became extremely bad in my 50s. And that's quite typical for many people. So when I turned about that age, I quit my work. I was teaching at the university, working at Max Planck Institute in Germany. I quit everything to research what was the cause of this thing. I said, I'm a scientist. I got to be able to figure this out. It's just not, it cannot be that tough, right? And that was at the time when my doctor was going to prescribe to me all kinds of really nasty medications, which I refused. And so I spent the next 10 years, almost 10 years, of reading every single article, every single book, everything I possibly could. And it came to the point of a serendipitous find one day when a book fell down and it opened up on a human cell. It was just a really amazing thing that by then I had enough knowledge to understand, oh, it's about the cell. Everything is about the cell. And it's truly every single condition is about the cell. And so when I discovered this, I was looking at that cell, and that was like a cartoon kind of thing with a lot of ionic channels, the sodium, potassium channels, and how the voltage comes and goes. It happened to be a nerve cell. And I said, oh, so maybe that's the problem. At that time, I had no idea. I said, so maybe that's the problem. So you know that we are always told to not eat salt, at least in the United States. You're not supposed to eat a lot of salt. They keep on pressing it further down. It's a high carbohydrate diet. And so reading these articles, it suddenly popped in that, wait a minute, we are eating a reduced sodium diet. We're eating a high carbohydrate diet. And one of the articles that I was reading said that the carbohydrates that convert to glucose kick sodium and water out of the cells. And so, well, what happens to the brain when there's no sodium and water ready for the cell as a result of all the carbohydrates that we eat and not enough salt? Then we can't generate electricity in the brain. And so I started experimenting. First, just with taking salt. People thought I was crazy. Would just throw salt in my throat and just drink it down with water. And it actually helped. And I said, wow, there's something to this. And so it still took a couple of years to understand the mechanism behind it and the genetic process. So migraine is a genetic condition. It's not something that you can have one day and not another day. You either have it or you don't have it. And if you have it for life. And if it disappears throughout your life, it's likely because of the changes in your brain, degeneration as you get older. But until then, I have discovered that the balance of the electrolytes in the brain for the migrainer are different from other people. So there's an article in 1951 that coincidentally showed that migraineurs urinate 50% more sodium out than other people do from the same diet. And so that was an eye-opener. So once you connect all these dots, you can see, wow, okay, so maybe it is just salt and carbohydrate.
You said that glucose pushes sodium and water out of the cell. Can you tell us a bit more about that?
I can tell just a little bit about it because I'm not really fully aware of the full mechanism behind it. But this is probably has something to do with the fact that in order for glucose to enter the cell, in some cases, not all, but there are some transporters that some areas where the glucose can only enter into the cell with the aid of 2 sodium ionized molecules. And so as the glucose enters the cell, those sodium molecules get kicked out. And with the sodium, because sodium retains water, also water is going to be removed. And in addition, glucose contains a lot of water itself. If you look at the cellular structure or molecular structure of glucose itself, you're going to see it's a lot of water. And so that too departs as the cell starts using the glucose. So there's a whole lot of mechanisms, and I don't know the full detail of what those mechanisms are. But if you look at the books, it's in textbooks, it's in medical manuals. And so it's definitely a fact, it definitely happens, and you can actually see it. So if, for example, you sit down today and you eat a little bit of sugar, and I tested this, and all the migraineurs have tested this in my group. We eat a little bit of sugar. Within a few minutes, we're going to start feeling our toes will start swelling, our ankles will swell, hands will swell. So some edema is happening. So what's happening? Well, the water is coming out of these cells and is entering into edema in places where there shouldn't be any. So it's definitely leaving the cells. And that causes a major problem then.
That makes sense. It makes me think that if someone's on a low sodium, high carbohydrate diet, their ability to uptake glucose is impaired, right? So maybe it's not technically insulin resistance itself, but it's almost like a form of that. Does it even make insulin resistance worse?
It does. And one of the problems with insulin resistance itself is insulin holds onto sodium. So why it holds onto it is never discussed. But I suspect it holds onto it because of these channels that require the sodium as transporters. So in order for insulin to be successful in getting rid of glucose from the blood, it needs to have sodium ready for it to push the glucose into the cells in those cells, which is why it would be retaining it. And so that compounds the problem that if you're a type 2 diabetic, and they tell you to reduce your sodium in your diet, then you actually reduce your ability to get rid of your glucose.
So let's say you have a high carbohydrate diet. You need to make sure you have a high amount of sodium as well. Let's say, for example, you're on a keto or a very low-carb diet as a strategy to reduce your migraine attack risk. So you're going to have less insulin secretion, which means more sodium excretion, more sodium loss. But the point is that there's less need for sodium, so that's not in itself a problem, right? Or do you still recommend pretty high sodium intake even on keto or low carb?
Okay, yes, I do recommend it. So let me just go back for 1 second to the diabetic patient, because that is a very important point to make, that when you have type 2 diabetes, you actually have a lot of inflammation and your kidney is retaining salt. So in that case, you may end up with high blood pressure as a result. So one of the reasons why they try to enforce that you reduce your sodium intake is because for sick people, sodium retains water in the kidney in a bad way and increases hypertension. This isn't true for healthy people. This is very true, though, for type 2 diabetics and for people with heart condition. So when you're talking about migraineurs, for example, who don't typically have any of the health conditions of a type 2 diabetic, they will not have the same problem. In fact, if you look at migraineurs, some of them have been with me for over 6 years, and by now I have thousands working for me. we increase salt tremendously in our diet. And there are 2 points to this. One of them is that the increased sodium, of course, is increased relative to what other people take, but we use more. Because like you said, based on the 1951 study, we excrete more. And there's additional information in terms of why we use more, because our brain is different. And this is a genetic difference, that the migraine brain is very different, much more connections or synapses between the sensory organ neurons. So the nose, the eyes, and the ears, and so forth. So we actually use more because we have more connections and they use more sodium. So when we take in more sodium, that isn't necessarily more sodium because we use all that more. So we don't know what the actual range of recommended salt intake would be for a migrainer. We don't know that. So we just experiment to see at what point does the migrainer reach the level of no migraines? And that would be then an ideal electrolyte balance. And that usually happens at 2 to 3 times the rate of the USDA. So it's significantly more.
So 2 or 3 times the recommended daily intake, you mean?
Right.
I see. So on that note, there's a lot of focus often on salt intake, but as you've just discussed, there's a very important relationship between salt or sodium and glucose, but also between sodium and the other electrolytes. Can you tell us more about how you see the relationship between sodium, potassium, magnesium, and calcium as between people with migraines and those who don't?
Very good question. So there are significant differences between migraineurs and non-migraineurs. In terms of migraineurs, so let's talk about migraineurs first, since that's my specialty. Because we need more sodium as a result of using more, our cells use more. We also use more magnesium. Magnesium is responsible for opening and closing the gates through which the action potential and the resting potential, so sodium, potassium, exchange space inside and outside of the cell. So when sodium comes in, it's an action potential, so the voltage is started. And when the potassium comes in, sodium leaves, and that's the resting potential. So for the migraine brain, there's more magnesium also needed because the gates have to be open much more often than for other people. However, calcium and potassium appear to be different. For one thing, migraineurs seem to have more calcium genetically. I have found a couple of studies showing that there's more cellular calcium in migraine population. And the potassium is an interesting phenomenon. We all need to keep a good sodium and potassium balance. But it seems that potassium, because of its location being always inside the cell, it doesn't appear to have the same evaporation ratio, the same usage ratio. It's slightly modified, and we don't really need to replace it as much as we do with sodium. So I don't recommend for migraineurs to, for example, supplement potassium at all, whereas we supplement sodium and we supplement magnesium, and we also don't supplement calcium unless they have some issues where they have to, like osteopenia or similar. In terms of non-migraineurs, because they don't use more sodium than the typical average population, their need for the sodium is probably not more than what the USD, unless they exercise more and they sweat more and so forth. There are some papers and some books that argue that even non-migraineurs will need at the minimum 4,000 milligrams sodium, 45 milligrams sodium. They believe that was a Lancet study or British Medical Journal studies. 4,500 milligrams was the ideal minimum for all populations, including people with heart disease, in sodium, not salt. So sodium is 40% of salt. And magnesium, we don't really know what the ideal level of magnesium is. The RDA is 400, but we know that the RDA is 400 milligram, that is. But we know that the RDA is basically establishing what the minimum required for life. It isn't necessarily the ideal. And so we can't really go by that. It's, again, a trial and error for each person of how much they need. In terms of potassium supplementation, I also wouldn't recommend that for non-migraineurs. Potassium supplementation has some really bad side effects. Potassium, as noted earlier, should be inside the cell, not outside. So when you supplement it, it goes into your blood, so temporarily it is outside. And if you have no need for potassium in your cell, it's going to remain outside. And outside of your cell is going to cause trouble. So, for example, marathoners or other athletes running and dropping dead in the middle of a game or middle of the running, or even baseball, basketball, any kind of player. We've had many cases in the past. They just drop dead. And basically, they always say, well, the heart stopped. Well, yes, the heart stopped, but why did it stop? It's usually because the extra potassium. So when you exercise, you bring up a lot of potassium out of your cells, and that can cause arrhythmia. So we don't want to supplement potassium. We have plenty as long as we eat a good diet full of potassium. And that's actually a point that we haven't talked about, is the importance of dairy. Like a lot of people are against dairy, but for some subgroups of the population, they're extremely good. And migraineurs fall into that subpopulation. So while the majority of the population is lactose intolerant, nearly all migraineurs are lactose tolerant. So it's a different group of people, obviously.
They're more able to make use of dairy, you mean?
And not only make use of it, but actually, if somebody is about to come down with a migraine, drinking milk can actually take it away. It's a perfect electrolyte.
So partly because of the calcium and potassium, you mean?
It's the potassium and sodium. Milk has a lot of sodium in it as well. So the sodium-potassium balance is actually what we're looking at. The calcium is just a byproduct that happens to be good for us. It doesn't matter because we have plenty of calcium. But for us, it's a sodium-potassium balance that is important. And there is sodium in milk. And many of us may add more salt into milk. We try to go with 1-to-1 balance with sodium to potassium in our meals. So we try to balance everything. And then we take extra sodium aside of that.
Okay, so when we ingest food that contains potassium, obviously it passes through the gut, and from there it's absorbed through the gut lining and gets into the bloodstream, right? So what is it about potassium in a supplement that's a problem? Is it because it's absorbed too quickly? There's less control over how much is in the blood at any one time. Is that the problem?
Yes. What we used to call it hits the heart. So it's a very fast, if you take it as a supplement, it's a fast amount suddenly, and the body doesn't know what to do with it. If you consider how potassium coming out of your blood cells, the red blood, and goes into the cells, it requires sodium to come out. There is an exchange. These two, sodium and potassium, always compete. They're both a positive ion. They can't be in the same place or repel each other. So potassium cannot go out of your blood until sodium allows it to. And so unless you're working really hard, doing something where you need to have access to sodium, or you're resting and you're doing absolutely nothing and your sodium is not needed inside your cell. And that's another point, that when you work out, your sodium is inside your cell, running a lot of the action potentials for your cells. So your muscles are working and your heart is pumping more than what it normally does. So at that time, the potassium is not going to get inside the cell. And so that then causes a pileup outside of the cell, which then it's in your blood. It can then affect your heart. But if you're eating food, it's like I said, it goes through a metabolic process. So it's per bite, as the body needs it, will be released.
Yeah, that makes sense. You mentioned that physical exercise also releases potassium from the cells. That would include muscle fibers. Is it a breakdown of muscle tissues through exercise that's causing potassium to be released? Or is it more about the mechanism of, say, fluid or other exchange between the sodium-potassium compartments?
It is my experience that it isn't the muscle tissue, because if it were, then it would not necessarily disappear so easily afterwards. So it's more likely that the cells themselves that that create the voltage for your muscles to be able to contract use more sodium at the time of exercise. And so what I have found is, and you may have found, and other people I work with have found, is that when we run, I'm an avid sport person, so I get a lot of, for example, jogging and hiking, and I will start swelling up, literally my fingers and toes after a little bit of running, maybe about a half an hour after that, I'm going to start swelling. And some people may feel even tingles and so forth in their fingers and your toes. And so that will be the sign that you really should be taking some sodium, because the potassium has exited from your cells and it's in your blood right now, and it's causing swelling and inflammation, and it doesn't know where to go and what to do. And so when you take sodium, it allows the potassium to also exchange again. So it allows more exchange, and it removes some of the swelling from your fingers and your toes. And then after whatever your marathon or whatever you're running, then it's another story to be able to remove all the fluid that built up as a result of the sodium, because you also build up fluid as a result of the sodium. So then you evaporate some while you're exercising, but then after that, you may want to increase some of your potassium to get rid of it. But during the workout, I would like to see some paperwork on that of what the exact mechanism is. I have not yet found any. I really think that it has a lot, and it's not from every exercise. Like I also weightlift. It doesn't happen from that. So it has to be something very specifically where all your peripheral muscles are working, as opposed to when you're just working certain muscle ranges, very high intensity. Like when I lift, deadlift, I don't have any problems. But if I run for a half an hour, I do. So it's a different mechanism between the two.
Yeah, I get exactly the same thing. It's consistently, anything like 20, 30 minutes of cardio or more, I'll basically get temporary bloating where I was like, was I that flabby? And then the next morning I feel dry and look great. But it never happens with weightlifting. So I can totally relate to that experience. It kind of messes with your mind, but it's interesting, kind of reassuring to understand the mechanism behind that. One thing you said earlier was about migraineurs having more cellular calcium than people who are not migraineurs. And you've also mentioned that they have a greater need for sodium. So that to me kind of makes sense, because we know there's an interaction between sodium and calcium, that an increase in sodium intake displaces calcium. So if there's a greater utilization of sodium within the body, that might explain why less calcium is lost from the body.
Exactly. And so it's also very important for people who have, for example, osteopenia, to understand that the connection to sodium and magnesium, basically all of these are connected, interconnected. So you really need to make sure that your proper balance is achieved. And I don't think that there is one proper balance for anyone. I think everybody is individual. As we can see on migraineurs, we clearly differ tremendously. And whereas migraineurs are provided with all kinds of medications that block calcium channels, it is so much easier to just simply take sodium, because that reduces the amount of calcium inside a cell. And it also allows at the same time more action potential. So whatever extra calcium is in there, there's then more action potential can happen with more sodium. And so it can literally be used better.
Perhaps we should take the RDAs as a baseline, but then the question is, what adjustments do we need to make to that based on our lifestyle? Whether we're highly physically active, we're doing lots of cardio, or maybe just weight training, for example. Whether we're younger, whether we're older, whether we're on keto or not. Maybe if we have any conditions like migraines, for example.
Exactly. In particular, and not just migraines, if you're looking at other health conditions, depression, seizures, just about every single one of them somehow are connected to the ionic channels, which would be calcium, sodium, magnesium, phosphorus, and so forth. So absolutely, we need to look at every single one. And if you look at them and if you look at a ketogenic diet, the good thing about the ketogenic diet is that in addition to it getting obviously rid of the carbohydrates, which are a huge cause of the disturbance of the electrolyte, it also then, precisely that the ketogenic diet reduces your level of insulin. So the amount of sodium that your body has is going to be reduced. So the first thing that happens when you start the ketogenic diet, or it could be carnivore diet, low-carb high fat, like most of migraineurs get into ketosis from low-carb high fat. So we're talking about entering a state of ketosis and the reduction of insulin. So regardless what diet that is, if your insulin is reduced, then the amount of sodium from your body is going to be reduced as well. So many people report keto flu, for example. And one of the reasons for keto flu is the lack of proper electrolyte balance. And it's very difficult to test for, obviously, and everybody is different about how much electrolyte they need. I never experienced keto flu because I was really increasing my electrolyte as a result of my migraine. So it's a happy coincidence that I didn't have to worry about my electrolyte because I increased it as a result of migraines. But those people who have no migraines may not know that. And I see some people, particularly carnivore, that they cut salt and they cut water out of their lives and they're just doing meat and fat. And that's not going to be sufficient on the long run because they need to have excess sodium at least while they're starting ketosis and the body is getting rid of a lot of the insulin is lowering and getting rid of a lot of water and a lot of sodium. So there's a lot to be said about electrolyte maintenance for all of these special diets.
Yeah, I think also something you've talked about and James DeNicolantonio has talked about, but it's very common that people think, okay, you need to increase your electrolytes on the keto diet. You're losing electrolytes. It's true, but actually we need to increase electrolytes on the non-keto diet as well, right?
We do everywhere. And also when we're talking about electrolytes, a lot of people talk about or think about electrolytes as water, sodium, potassium, magnesium, calcium, some even put vitamin D and glucose and everything in there. And that's not a true electrolyte. So that's another thing is to define what we actually mean by electrolyte. And so now James wrote a very good book, The Salt Fix, in which he's talking about the amount of salt people need who are not migraineurs. And so he is about twice the RDA recommended value with his book. And I'm saying that migraineurs need even more than that. So James and I talked about this actually, and I find him to be conservative, but he has an interview with someone that says that, for example, for training, before he goes to the gym, he will take, I forget now if it was a half a teaspoon or 1 teaspoon salt. And so that's a pretty good preparation for physical activity, I would say. And that also goes for migraineurs. Not to that degree, perhaps. I will, for example, take 360 milligrams sodium every 20 minutes instead of taking a whole teaspoon before my workout. But basically it comes to the same level.
So even the sodium RDAs are a bit ballpark, but would you say that as a very rough rule of thumb, it's double the RDA if you're highly physically active and maybe 3 times the RDA if you're a migrainer? Is that the general feel?
I think that's a pretty good generalization. And of course, it depends also on your health condition. Like I said earlier, if you have diabetes or if you have heart conditions, then obviously things differ because your kidneys don't work the same way. There are also some genetic conditions that's called the salt sensitive hypertension, which is quite rare. But in that case too, you may want to watch at the beginning. However, even in that case, I read some studies that all of these are really metabolic issues. So there really isn't a genetic problem. We're talking about a metabolic condition, which if you improve, the kidney can improve. And I have proven this, that the kidney can improve. Many of my, not just migraineurs, I have people coming to the group who are not migraineurs just to improve their health. And the kidney function has improved and other things have improved with increased salt, provided they modify their diets by removing carbohydrates.
Yeah. And I think it also comes back to the point that it's great for people to find diets that work for them. Self-tracking can also be very helpful if you're taking supplements, but it really starts with the building blocks about what goes in. You can only optimize what you already have. And I think there's a lot more awareness now that health is wealth and it's something to really invest in. So on that point, are there any words any message in particular that you really feel you would like people to be more aware of in terms of their own health for their daily lives?
Yes. So it's not just, everybody's crazy about counting calories and looking at the macros of what they eat. But I think that the quality of what you eat is a lot more important. So when we're comparing, for example, the kind of meat that we eat, if you can afford a better quality meat, but eat a little bit perhaps less or less often, it's probably better for you than eating more of the less healthy meat. And as you said, in terms of investment in your health, if you're looking at medical bills versus eating the healthy food and where you don't have to pay for your medical bills, there is just going to be a huge difference in your expenses, and likely you will be saving money on the long run.
Yeah, I can't agree more. That really leads me to say thank you once again, Angela, for joining us. Really appreciate your range of interests and experience, and I highly recommend those listening. Please do check out Angela's blog at hormonesmatter.com. That's hormonesmatter.com. That's how I first found her. Some really interesting articles and just taking complex concepts and making them simple. Thank you once again.
Thank you so much.
Thank you for listening to the BSU podcast. Please subscribe to receive a new episode every 2 weeks and visit our blog at www.bsu.bio/blog to get a full transcript of this show, as well as other content to help you know and grow yourself. Until next time.